Okay, I think we're live. Hi there. Um, so today we're going to be talking about Web3 technologies. I guess the last two times you've seen me lunching and learning with the front side on YouTube, those were presentations about blockchains. Um, I think I can speak for most developers at this point when I say we're really sick of hearing about blockchains. But that paradigm has sparked a lot of kind of innovation, so much so that it's hard to keep up with uh, in the realm of decentralized and distributed applications outside of the context of the blockchain or a blockchains. Um, and what's emerging is we're starting to see blockchains are uh, a piece, often a small piece of a larger kind of stack. And there's a lot of exciting things going on in that space. So that's kind of what I've been messing around with in my free time, and I thought maybe we should talk about that today. Um, so I believe I can screen share. View. Um, the entire screen. Hey. Okay. So you should be seeing a PowerPoint presentation now with 4 luxurious slides. Let's see if I can go into present. Yeah, so Web3 and IoT. Specifically, that's the domain I've been applying it to, and I think it's one of the more exciting domains where we're going to see a lot of rapid advancement. And the subtitle here, client server free is the way to be, represents kind of a paradigm shift we're seeing that's emerging, where peer-to-peer communication is taking the forefront. So, so let's talk about the why behind this before we get into what some of these technologies actually are and what IPFS is. This whole thing started for me when I wondered, why can't I scrabble vinyl? If you're not familiar with the term scrabbling, it's essentially a form of microblogging all the music that you listen to. So Last FM would be an example, or Libra FM. By keeping track of these things, you can, it creates a really interesting corpus. You can actually see like, oh, in November, my mood was darker, and I listened to more, of music that evoked, a sense of dread or something. Like you can get really abstract kind of information pulled from that. And I guess I just thought, surely this has been done. And I looked, and it's been attempted a couple of times, but those projects were kind of abandoned. And yeah, I mean, it seemed like an interesting problem. The more that I dug into it, which took me all over the place into, the white paper that spawned Shazam and several other white papers related to that, and also kind of some of the existing solutions like AcoustID and Music Brains for metadata, and it took me down a lot of avenues. But at some point, it dawned on me, why? I think the moment that it dawned on me was so AcoustID stores fingerprints, audio fingerprints. Sorry, acoustic fingerprints of audio. Using those, you can identify audio files. They also release a full dump of their database and schema on a like a quarterly basis, basically, which amounts to 200 gigabytes or something like that. And they just put it out there on FTP. And it's like, if you want, to do your own research with this corpus of data, or if you want to like keep up with, what we have without access to the internet, that's your option. Is you buy a big old hard drive and you get the newest data every quarter. And in my own experience, I know with Music Brains, which is kind of an associated project that stores metadata, um, it's woefully behind the times. I would often go to add some brand new mixtape to my library and find that, of course, it hadn't been indexed there yet. Now, to contribute to these databases, you have to register for an API key, but they're free to contribute to. And I guess when I was thinking about kind of how antiquated this felt, I thought about IPFS and what I had known about it thus far. So we'll get a bit more into what that actually means later, but basically, I don't see why there should be a central authority for these things. Why aren't we just sharing our library's metadata? Anyway, a little bit off track. IoT in general, though, to kind of pull it out of that specific problem, it's needlessly centralized. I think the first podcast I was ever on with the front side was about IoT. And I remember just really pressing the issue as much as I was comfortable at the time that I don't care what, Amazon's user agreement says. I don't care what Apple's user agreement says. I go over to my friends' houses, since I moved to New York, and everybody has a HomePod and everybody has an Alexa. And I don't see how you can live with a microphone in your house that is just on all the time. But I at the same time am fascinated by home automation, and I want that. Why is it that if I want to have a conversation with you and you're in the same room as me, I don't yell at the clouds. I talk to you. Why can't I issue a voice command and then have whatever receives that just directly talk to the devices in my house instead of phoning home for some type of whatever it is, to some platform. I don't know if you've ever been around, the AWS console or the Google Cloud console, but they're like these massive, insane things. I know that, just the pain of dealing with AWS's Internet of Things state management was a large part of the reason the Lights project that we had stagnated. And even then, it kind of didn't make any sense. What does Amazon need? Like, what does that have to do with our light bulbs? Why can't we just handle it? So, yeah, you're not in ownership of your own data. And for things like machine learning, and this is something that'll take a while to change, although there are some very interesting projects coming out along these lines. But if you wanted to have like sentiment analysis done on a voice command, that type of stuff is heavily takes heavy computation. It has to be done in a server farm somewhere, and that costs money. And you're dependent on that now for a workflow that you've adopted into your lifestyle. And the most egregious example of this is that you're dependent on these services for data. If I like back to the kind of the idea of audio recognition, there was a company called EchoPrint that came out and offered this kind of they had an open source toolkit for generating landmark fingerprints, and that was bought up, I think, by Spotify. And basically, like, this has happened over and over again. Grace Note is a good example of this. These are services that charge money simply to give you access to a corpus of data that they own. And, everything we do on the internet, everything we do with computers, everything we do with devices generates data. Why can't we harness that within, the confines of our own home and utilize it and have our systems and our homes and our devices kind of grow organically? And that's sort of the idealized version of what I'm what I've been working on the past several months and what I've been trying to drive towards. So, talk about IPFS. It is the Interplanetary File System. Yes, really, that is not a joke. This is the brainchild of Juan Benet and what has now become Protocol Labs. They have several projects kind of in this realm. IPFS was the first, and I believe the first anyway. But from that has come multi-formats and libp2p, which is an incredibly important library. So there's a lot of interesting work coming out of Protocol Labs at the moment. IPFS specifically is a, kind of it's a file system. It's also, a new way of looking at the internet. It's important to note, and you'll see this graphic in just about every YouTube video on this subject. It's important to note the difference here between decentralized and distributed. Decentralized, you kind of have these dendrites, right, or axons, I guess. It almost looks like a neural kind of network, right, where you have hubs, but you still have singletons. You have singletons. It's if this, I don't know if you can see my mouse right now, but like if this, little dot goes down, then all of a sudden, these that are connected are no longer able to access anything on the network. So while the damage is contained, and it is much better than a completely centralized model, it's not, it could be better. Distributed is, this idea that everybody takes ownership of the entire thing to some extent, right? Not everybody has a copy of the internet on their computer, obviously, but a good way to think about it is BitTorrent, and that was actually a large inspiration for this project. When you download a torrent, you're downloading it from a swarm of peers, and either a centralized tracker or a distributed hash table directs you to which peers have the data that you want. But everybody holds, a piece or or kind of a complete album or just a couple tracks or whatever it is. You're still getting, 4 kilobyte chunks at a time from individuals on the network. And that's kind of what we're dealing with IPFS, right? It also takes a lot of inspiration from Git because the kind of what is behind it is this thing called a Merkle DAG, which is a lot like a Merkle tree, but it's a decentralized acyclic graph, and it's versioned essentially. So like the leaf nodes, basically you have like an origin state, and you also have the ability to kind of like merge off, of these various states at any point. But basically, it's append only. You keep getting change sets, and so at the end of every path is like the most recent set of changes essentially, and then that is cryptographically secured similarly to how a blockchain is. There's no decentralized consensus, but they're linked back in such a way that you can create a reliable history of a piece of content, in this system by tracing it back through its lineage, and that buys you a lot. There's no, gas prices here. There's no paying. There's no mining blocks and paying for transactions to be minted to a chain. It's very lightweight, and while Filecoin is another thing that they're working on that will kind of incentivize this financially, that's more geared towards enterprise. And right now IPFS exists as a free thing that basically you get to use just by participating. When you browse IPFS, like when you browse the IPFS internet, essentially you are downloading files, just like you would, download static content from any website, and they stick around on your computer for a little while, and you're just giving people access to that cache, anybody who wants it, essentially. And then that gets garbage collected unless you explicitly tell it otherwise. So it's kind of this ephemeral piece of the internet that lives on your computer at all times. Um, and then yeah, objects can span multiple blocks. It is kind of like a file system in that regard. There was one attempt at this before called SFS, which is kind of interesting. I think it's Self-Certifying File System. This was in the year 2000, and it was an attempt to do this across Unix networks, basically, for large organizations. And it never took off, I guess. It was not for the wide area network, and also it was just some doctoral theses, I guess, don't make it. But yeah, so these are kind of the roots of IPFS. IPFS, in the process of implementing it, spawned libp2p. I'm not. I did a ton of research into this last night. I'm going to spare you it because the past few of these have been very wordy, and I want to get to the demo here. But libp2p is a suite of protocols and specifications, and it is actively being developed. There are a few implementations, none of which I think are complete at this point, but and the specification is still in flux. But what it has afforded is things like Orbit, not Orbit.js, but OrbitDB. So really easy CRDTs now, really easy peer-to-peer communication just in any respect. Like Matrix would be one example of that. Computes.io is a supercomputer that you can participate in. Yeah, I don't know. It's just a very cooperative kind of environment that's coming as a result of just this library and the growth that it's undergone as of late. Another really important thing to note is that the IPFS is content addressable. It's an internet. What we have now is an internet of addresses, right? You go to an IPv4 address or whatever, or after a domain resolution, and you get what is there at that moment, right? If you go to Twitter right now, it's going to be different than it was when you checked it this morning. And, that isn't like, I don't know, the address, it's a layer of abstraction that doesn't really need to be there. What we need to be, addressing is the content directly. So when you go to an IPFS address, it is literally a hash. It is a hash of a piece of static content. And you broadcast out to the network, hey, I'm looking for this hash, and anybody who has the chunk of data that corresponds to that hash is free to serve that to you. And it can be many people. So that's kind of interesting, right? It also within the network allows for the avoidance of redundance or whatever. There is sort of exactly one copy of a thing at any given time, or one, I guess an address only ever points at one thing. Therefore, they're kind of objects in this network are immutable. Anytime that you change it, it becomes a new address. And so they've actually, one of the biggest hurdles has been naming, like sort of an equivalent of a domain name service. That's been a very hard thing to deal with in this space. This has been, archive.org is already involved. Project Gutenberg is already involved. Several university libraries are already involved. This is like archival was, it's just immediately an instant sell. It's taking load off of, like archive.org doesn't have to sit here and archive the entire internet forever anymore, just on their servers or whatever. And more than that, it just, the disbursement of the information makes it more permanent, essentially. It's impossible to censor as a result because the only censorship essentially is obscurity. If nobody, ever requests your content, then that content lives on your computer and your computer alone. And if your computer goes down, it's gone forever. But if it's something like Wikipedia, or GitHub or NPM, which has an IPFS mirror, that's gonna have, it's gonna have better uptime and also just a better chance of kind of living forever. Um, Also, high performance and low latency. You're like traversing this is often it's kind of thought-wise harder and maybe computationally harder, I guess, which is kind of why lib2p P2P is so insane. But stuff is closer to you, right? You're more likely to find the content you're looking for on the edge of this than you are at the center. Which is nice, kind of, especially in developing nations where there is censorship. Like, that's a nice combo. It's very fast, and it is unable to be killed. So applying this to the IoT domain, this can help alleviate privacy issues associated with these devices that we see emerging, these smart home devices. The thing that interests me most is kind of the combination of, and I haven't been able to actually find the paper behind this. I've just seen it referenced in other papers. But Microsoft did work with IoT that kind of, they were like shocked to find that when they had, appliances ranging from like refrigerators and washing machines and, tablets and phones and whatever, in this kind of simulated smart home that they set up, when they used, and this was long enough ago that they were using BitTorrent, I think Ethereum and something else to kind of handle the communication, but they eventually found that like the devices learned to kind of cooperate in an almost human way. A device that had maybe more memory available, would be able to kind of shoulder that burden a bit more. And then, a device that had a better connectivity, with the outside, like a more reliable internet connection, than say a washing machine, would happily broker the communication for the washing machine when the washing machine needed to buy its own, detergent re-up. So like that really blew me away. And then kind of research that came out this year on it, and this is sort of what I've been trying to replicate and expand upon, is this paper, IoT Data Privacy via Blockchains and IPFS. And this is where we kind of, I think I've talked about this in Slack before, but I mean, basically, it's similar to the setup that Microsoft had, and it utilizes IPFS and I think also Ethereum, but private Ethereum blockchains and hierarchical blockchains, right? So you have kind of a consortium of related devices that share information freely because they can all benefit from it. And around the outside of a few of these little communities of devices is an access layer and sort of an overseer node that has its own blockchain about which communities can talk to which communities are more reliable, and then if anybody wants to come in from the outside and access the data that is being collected by any of these, consortia, that access can be mitigated through that outer blockchain. And so that's where it's like, blockchains are an adjunct, but we're finding they're ridiculously inefficient, and also the user experience is just terrible. I tried to write a blog post just explaining how to write a basic D app, but there's dozens of them and they're all equally annoying. It's like you got to install MetaMask, you got to buy some Ether, or do it on a kind of a fake network. If you try to store the Ethereum white paper on Ethereum, it would cost about $40,000. What we're realizing now is we can just store an IPFS hash in a block. And now we have a history of, large amounts of data and their flux over time. So that's a pretty powerful thing. I think this is the last slide. Um, what happened to the Hangout? Oh, what? Hello?
Hi, we still see you on video now.
Okay. I wish I could find the window because I do want to be on video. I want to start showing you guys devices and stuff, but I don't know. There we go. All right. Cool. So, what does this actually look like? So I've got a few devices scattered around the house right now, which is why I'm in my living room and in my office. And I set up kind of just a demo system to show kind of what what this stuff's capable of. So I have a private. I have 3 nodes right now that are in a private IPFS swarm, and they, yeah, so yeah, they can talk to each other essentially. I have my computer, my laptop, where I can kind of send messages out to the other devices. I have this little guy, which is a Pi0W with e-ink on it, and like a little e-ink hat. And then in my bedroom, I have a Pi B12 with my webcam attached to it, and that's just pointing out the window at Harlem. And we'll take pictures, and then other things will happen as well. So let me fire up. Actually, I guess I should go back to screen sharing for the time being. Okay. All right, so camera is the Pi that's in the other room with the camera, obviously. 0W is the Pi 0W. Oh, right, I was holding it in my hand, it's not connected. So here's my MacBook. I have IPFS installed and running now. The Go implementation. There's a Go implementation and a JavaScript implementation. And then everything else is kind of small potatoes. So what I can do is I can, look at the swarm, right? And right now I just have one peer, and that's the Pi that's in the other room. So what I'm gonna go ahead and do now is plug in the Pi 0.
Hey Joe, can you increase the font size?
Yeah. Story of my life.
Thank you very much, sir.
Anytime. Okay. Oh. Is that better?
That's better, thanks.
Okay. So, the Pi 0 is slowly kicking on. Oops. Eventually we'll see it show up. No. Eventually we'll see it show up here in my peer. There it is. So now it has joined the swarm. And this is the type of thing that like you might want to record on a blockchain, when a device comes online or comes off a line. And I'm not talking about, Ethereum or Bitcoin. I'm talking about just a lightweight personal one, which there are platforms for that now that are pretty cool. So if that's online, that means I can get into it. With my default username and password, of course, that I never bothered changing. Man, these zeros are slow. So, right. Let's see. What was that called? Notify agent. And then over here on the camera, I'm going to go into camera agent. I wrote 2 little node processes that are going to sit here and poll. And one of the things that IPFS provides is pub/sub. Now, why might you use, IPFS's pub/sub over something like MQTT, which is sort of the default in the IoT world right now, or at least a well-respected standard? As far as I understand MQTT, you need a broker in between peers to mitigate or not mitigate, to handle the communication. So I'm not sure if that's something that can be done locally, but basically it's not direct peer-to-peer, whereas this is. And additionally, like the broker's job is to communicate, or is to take like a communication from one device that it might be in one format and translate it into like refrigerator format or whatever. But through things like multi-adder, which for instance you can see an example of this here. This is an address that specifies like multiple protocols, transports a port number for the TCP, a hash for the IPFS resource. Like these can all come in basically. Instead of a client server architecture, there's a dialer listener architecture. And what happens is a sort of handshake where a peer will say to a peer, hey, what are you capable of talking to me in? And it'll get a list. And if both peers are capable of multiplexing, which is, I believe, enabled by default on IPFS, you can actually get stuff through that IPv4 address over TCP, through IPFS, through any number of protocols and transports, all multiplex through one socket, and just blam right into your understanding. So it makes the broker in MQTT look silly, basically. So PubSub is nothing new or special, but it is kind of neat in this context. So the camera agent, forgive my vimming, and also kind of crappy code, but basically this is just going to take a picture anytime it hears a message on the image capture topic. So in this PubSub model, we have topics, and the reason that I've kept this network private is because, as far as I can tell, it's still in development, having private topics. Or at least it's not particularly straightforward. So if I were to have this on the open IPFS network, any peer could shoot messages into this topic. Yeah, so still stuff to be worked out. But I can fire a message off through here. It'll be received and it'll be reacted to. And the reaction is that it'll take its picture. It will add its picture to the local IPFS. It will pass the hash for that picture to the Pi0, which is listening on this notify topic. And the Pi0 will display for me over here in the living room the hash that I need to go to actually view the resource, so that I don't have to get up and go look at the picture in my bedroom. And that's sort of the flow of things. Like if we look at a notify agent, it's very bare bones and just basically invokes the Python bindings to write to that e-ink display. I think these are mostly working at this point. I kind of got into a groove with it last night. And then here. Okay, cool. So these are both ready. And then what I can do is IPFS PubSub pub, and then I think it's what snap. I think might have been the message that I used. All right. Wait a minute. That's no good. I forgot to specify the topic. Okay. PubSub is also, I should note, still, I think, alpha or something. All right, so I fire that off into the network. The camera hears it. It takes a picture. The Pi0 hears it, and it's now written to the little screen. Unfortunately, here, and I can stop sharing momentarily. I don't know if you can see that this. I didn't have time to write a nice kind of this view for this, so it's like unreadably small on there, defeating the whole purpose of the exercise. But I can just grab it off of here, and I can show you guys what's kind of cool about this. So basically, yeah, the picture was taken over there. It was added, and then when you add it, you get a hash. You can add, directory structures. You can add single files, but always what happens is that you get a unique hash representing that resource and that resource only. And in fact, if I were to go and add, say, Pepe the Frog or some common meme that there's, a bunch of already on the internet, I would get, like that hash that already exists on the network. I wouldn't get a new one for my specific copy. If the file is the same, the hash is the same. So yeah, all right. So this now represents a file on the IPFS network, where it is actually stored thus far is only on the Raspberry Pi that has the camera attached to it, because that's, it is now added it and said, hey, I have this thing, but nobody's actually gone and gotten it yet. So there's only one copy. The cool thing is that I can, either download this directly, or through a browser, I can go through a gateway. So this spins up a gateway on 8080, and I can go and pass the hash, and it just pulled it right off of the computer in the other room. Because, yeah, normally when you think localhost, right, you're thinking that's a file that's local in my system. If it was local in my system, it would have gone there first, but it just, went out across the vast, graph of the 3 peers that I have on this network and found the closest one and took it from there. And so that is the view out of my bedroom window at the moment. This also can be, I tried this earlier. Like they offer a public gateway so that you can. It's been unbelievably slow though lately, because things have. I guess there's been a lot of interest in it. But basically, that if I kind of do this, this will come and request it from my computer, store it on its server, and then it will be connected to kind of any node on the network. Now, yeah, there is no incentive to duplicate things, and there's no guarantee that anybody will actually come after the content that you put on here. So it's not a like a 100% reliable redundancy solution, but it is a really easy way to share potentially large, entire files of information instantly between peers on the network. So yeah, that's about as far as I got with that. Any questions on that, or extensions potentially? This is still very early stages, obviously, but nice little proof of concept.
This is cool.
Cool. Yeah, it's neat.
Have you tried? So I mean, you've got like the hash printing out on the e-ink. Can you actually print out the photo on the e-ink?
Yeah, we could.
That's pretty cool.
Okay, let me actually try doing that. I haven't set it up to do it automatically, but I can every time.
I mean, yeah, it'll be like a crummy version of the photo, but it'd be really cool.
Entire screen, sure. All right, so we'll pop over to the Pi 0, which still doesn't have a local copy of this. It just received the address to it. So if I were to go and say, like, I think if I do IPFS LS, Nope. I guess that needs a hash attached to it. The other thing is these get mounted. Refuse. So right now I have nothing in my local store, basically. But if I do IPFS get and then the hash, just like a wget, you can even IPFS cat and pipe it into whatever. So now I think if I do, I guess maybe it doesn't show up there, but now this is stored locally, and anytime I want to go reference it, I'll just look on my own machine until it gets garbage collected. I should note that I can also pin it, and now it will stay on my machine forever and never be garbage collected, which is I'm just trying to hit as many features as I can as we get to this. So now we have this thing. Actually, you know what? Let's get rid of that and do this. Then, to actually, I don't even know if I think that might be in the global path. Okay, I do. Oh. Hmm. Whoa, okay. Yeah. Here. And there it is.
Nice.
Yeah.
Yeah, it's super crummy, but yeah, it wait, it's awesome.
Yeah. So yeah, eventually blockchains will have to be involved, but for now, it's been nice avoiding them. And I'm hoping to build a cooperative system. That's the kind of the ultimate goal here. But I hope y'all got something out of this piece of it. Any other questions I can answer about IPFS or stuff going on in this space? Okay. Gonna take that as a no. So thanks for your time. I'm sure the Ainsworths are there by now, and I'm jealous. Cool. I will catch you all later, and I'll be back on after lunch and down to Pair on whatever. So see you.